4 o'clock. Let's start. So is everyone here? Raise hand up if you are not here so that I can wait. I think almost everyone is here. So let's open the week 7 slide. Can you open this slide for me, everyone? I will copy this link on the message. So please come on in the slide so that we are going to work on this slide back and forth with this slide and the Jupyter notebook. We are heading toward almost the end of our entire training program, and this session, probably this second half and the first half of the next week, is going to be pretty much the recap on what we have done so far. So I'm going to go very slowly so that please work on this on your machine together and then fill the values on this slide, and let's make sure that everyone just do it now, step by step, or together. Okay. So the objective of this slide or this session is going to be build 2 different scenarios using the CSV file. One is BAU, and the other one is renewable energy scenario. Then we are going to compare generation mixes and emissions and the cost. Here, cost means marginal price, right? And then we are going to try capacity expansion of minimum renewable energy with renewable energy capacity. So basically, we are going to set the minimum amount of capacity expansion of renewable, and then we will see how much renewable is going to be needed. And then we will see how economic dispatch would change the order or would change the generation mix. So BAU scenario is the current scenario. It's basically the file that I provided. And we are going to make new high renewable energy scenario, but I'm not sure we are going to use energy storage capacity. Probably we don't need it to, but we will try to see if we can. Okay, first, let's go to the file of your own country, and then let's open the generators. And we are going to just review this file to see that we are on the same page, to make sure that we are on the same page, right? We have generators, bioenergy, coal, gas, hydro, nuclear, other fossil, solar, and wind. Some countries might have other renewables as well, right? And all generators are connected to bus, and it has PNOM, which means the capacity in megawatt. And we have CO2 emission and the efficiency and marginal cost, and then capital cost of each system. And each of them are connected to a proper carrier. So in case solar and wind and hydro, they are connected to renewable and bioenergy as well. And then nuclear is the only one connected to the nuclear carrier. And we have fossil fuels. They are which include coal, gas, and other fossil. Right? Let's close it. And I'm going to change the name of this Indonesia to Indonesia. No, not Indonesia. I'm going to work on Japan because there's no one from Japan. And I'm going to change the name to Japan BAU. Let's do it together on your own machine. And then we'll copy and paste. Copy and paste the same, basically duplicate the same folder. So we will create it with JP _REN. I'm going to use REN as a distinguisher. Are you guys have done it so far? Okay. Now jump into the generators file of renewable energy scenario. So we have two different scenarios, JPBAU and JPREN, right? But at the moment, those two are exactly the same scenario. So whatever you run, the result is going to be the same. So we are going to change the value of JP renewable and open the generators. What we are going to do is we will have Pinom extendable force to everything except wind and solar, and we will make Pinom extendable to for wind and solar, like this. What we want to try to see is what is going to happen if we have three renewable. That's what we would like to see. So any question, Abraham?
Yeah, I was just wondering if the PNOM extendable, shouldn't it be also be true for hydro and bioenergy?
I mean, it depends on what kind of a scenario you would like to try. But what I want to try is just seeing how solar and wind affected systems. So that's why I chose this Pinom extendable of solar and wind true.
Okay.
And then Pinom min is going to be the same with the current, so that there is no renewable energy reduction in terms of capacity. And Pinom max is going to be, let's say, 5 times more than now. Maybe it can be much more interesting if we just decide to go for at least twice. So in this case, we are saying solar needs to be at least twice than the current and below than the 5 times of the current capacity. And same for wind, more than twice, but below than 5 times. And then close it. Now we have two different scenarios. So we will go back to our notebook just to make sure that I don't have any like imported data from the previous session. I'm going to make a new notebook here. First, import PEPSA, always. Seems it takes a little longer than expected always today. Network, but in this case, I'm going to name the network as network BAU. PEPSA network, and then import network BAU from CSV folder, and then it is going to be in data. I used Japan, but with BAU scenario. And then let's see. Let's run it first, and let's see how it goes. Right, something is wrong, I think, again. So do I have the proper structure of this file? Why do I have it here now? I have my file in very strange place. So let me have some time to move it where it needs to be. Somehow I think I have to. Is it here now? My computer is not really helping me today. File not found error, which means I might have a wrong folder name. JPBAU on the data. Should be correct. Data JPBAU. Let me just recreate. Sorry, I'm just recreating new one. Yes. Now we imported one. Yes, basically Jupyter Lab is basically calling the file from the directory folder. So yes, it is updated there, but not really updated to your pipesa. So you need to re-import it. So yes, I'm going to upload my JPBAU and REN later. No problem. So you can work on your country, right? And then let's see how this JPBAU look like, which we did before. So there must be no problem at all. We are optimizing it. And here I send you the code to plot the output, which I almost always use it. So please copy and paste from the message. It took about 12 seconds, and then now we are starting to have the result step by step, optimizing it, and then please come on, do faster. Yes, now we can see the result. It is going to be exactly the same as we saw before, right? We have a bio and we have wind and solar and everything exactly same. Now what we need to do is to compare the result. We are going to create another network called network REN, which is another scenario. Types are network. And then types are network REN is going to be use the data from import from CSV. This is always confusing. I would like to say import CSV from folder rather than import from CSV folder. I don't understand the logic. JP REN. And then this time, I'm pretty sure this will work. So I will just optimize it right directly. Oh, yes. Now we have the output of renewable output of this renewable scenario. Right? we want to see the result, so that we are going to copy and paste the previous plot. And then we will change this. If it was BAU, I'm pretty sure it was BAU. So change this to REN, and you can plot it. Now we have a output with much more wind and solar, as you can see here, compared to the previous, which has a limited amount of solar. We have much more solar output, right? And then also we have much more wind. Almost wind did nothing in Japan, but now if we go back, we have gray, which is wind, and provide a lot. I wouldn't say it's huge amount, but still provides some meaningful amount of electricity to the grid, right? So let's copy and paste your result. Let's see what we need to put back into the result. So first, to analyze this output, what we are going to have is the capacity max of the system, right? So basically, when you analyze electricity grid or power grid, the first thing you need to start is the capacity. And the second one you need to check is going to be generation. And then third one is capacity factor and the cost and the emission. That's some sort of kind of logical order to see. So first, we need to see the capacity. So in case of BAU, the capacity is basically a fixed, right? So don't need to worry too much about it getting out of this pipe saw, but we can just copy and paste BAU from the generators, and then copy this pnom back to the slide. So can you do this on your own selected country? And then we have, in case of high renewable energy scenario, we can't just copy and paste because the output is going to be this. Output was decided by the model, right? We used capacity expansion. So what we actually need to run is network REN dot generators dot pnom op, which means pnom capacity optimized. So this is what you will get. So we have 5 gigawatt of biocoal, hydronuclear, and other fossil fuels are the same, but we have about 460 gigawatt of wind and about 29.1 gigawatt of wind, solar and wind, sorry, I mixed. So I'm going to copy and paste 458050. This is the solar, and we have the wind out. But the others are basically the same. Sorry. Let's just see how much wind and solar we have more. Basically, solar is about 5 times more, and wind is also about 5 times more, which means it kept pnom max. Pnom max actually basically kept the total amount of a solar and wind capacity, which implies that we can have more wind and solar if there was no cap in Japan. So if you are working on your own country, please fill the number. I already see the number from the Philippines. So same for the Philippines. We have about 5 times more solar and wind, right? What about Korea and what about India? So in to optimize, I mean, the optimization process that what we are using is cost optimization. So based on the numbers or the assumed um, cost values that we provided, basically having more wind and more solar is going to be economically feasible, definitely. That's what this model result is telling us. There's one person working on Pakistan and one person in India. And even if there is a number, if you think it's wrong, you can fill other values as well. While we are waiting the other people to the other countries have their own number, probably if you finished your work, you can try another scenario. Let's make it. I mean, this is just an additional scenario. So, but let's try to make renewable energy scenario, copy and paste it to the same directory. And then I'm going to rename it as a JP add. And then we'll choose the generators. I already have one generator file. So I will open generators file from JP add. Then forget this pnom and min. Delete them. Come on. Delete. And I want to turn the pnom extendable of entire generators to true. Just for fun. What is going to happen? So network add is going to be Pizza network, and then network add will get the data from CSV, right? Import from CSV folder and data JP add. I'm running my own code. Let's go back to scenario. We have the output from the Philippines, obviously, and then we are started to have a output from of Pakistan and Indonesia. Yes, exactly the 5 times more wind and solar, basically. So in almost all countries, having more wind and solar is economically more feasible. In this assumption, of course, always you need to say based on the assumption, assumption that we have, or based on the data that we have, having more wind and solar is economically makes sense. That's what we needed to say. We can't just say wind and solar is better than the others, right? We can't say that. We are doing this modeling based on the assumption that we have, right? So let's see the output. Network add generators key nom. So in case of this scenario where of Japan, that we don't have any Pinom min or Pinom max, what happens is we have lot of hydropower, because of course hydropower is a free source at the moment. A lot of hydropower and small amount of solar and the small amount of gas and coal. That's what happens. So that this is the reason why estimating your own renewable energy potential is very important. Without the proper potential estimation, in the end, you are going to have very strange number, which is not scientifically really makes sense, right? So that's really important part that you need to understand. So we have the output from all countries, I think. Yeah, we have output from Indonesia, and we have output. We don't need the output from India and Japan, and we have output from Korea, and blah blah blah, all of them all together. Now we are going to check. We are going to update our generation mix, as you can see here. We already have the result, right? We already have the chart here. Do we have the chart? Yes, we do have the chart. So what I'm going to ask you to do is right click it. You can find copy output to clipboard. Do it, and then go back to the slide of your country, and then change, add the slide here. Later, I'm going to change the size and everything, so don't worry too much about that part. But your BAU scenario on the top, and your renewable energy scenario on the bottom. But please put them in the generation part, not in the capacity part. You guys are putting them in the capacity. Come down to the page 14. Thank you. Thank you. Like this. Huh. Indonesia really don't have much wind and solar at the moment, right? So as we don't have much solar and wind in Indonesia, adding 5 times is almost nothing. Let's go back to analyze it. If we see the page 7, yes, solar, we have 600 megawatt and wind 150 megawatt. So that even in high renewable energy scenario, solar is only 3.1 gigawatt and wind is going to be 0.7 megawatt. Gigawatt. So probably, Abraham, if you like to, you can try to have even higher number rather than just between 2 and 5 times. You can try something like 10 times or up to 30 times or something like that. Yeah. And probably, Abraham, you may want to do it after this session and try and update numbers. That will be great if you can do that. Because we are gonna go to the next stage. So we have this generation pattern. Then what we need to compare the annual electricity generation amount, electricity production, basically, right? So let's go back to our Jupyter lab. Why do I always forget? Strange. Getting older means forgetting things. Okay, first we will try to see the annual generation of BAU scenario. Where is the value? Generators T. Why is it T? Because it's temporal, right? We want to see the temporal output of power and want to see the sum of it. If we just sum it, let's see how it looks like. We can see the annual generation by fuel. This number seems just too big to me because currently this is megawatt hour. So we are going to change it to gigawatt hour. Now this is the value we have for generator. So I'm going to have these numbers to BAU scenario. No need all the small numbers after the decimal point. Just big numbers, just integer numbers. And other fossil is 19412, and solar 135,139,538,12074. This is the amount of generation of Japan in case of BAU scenario. And now let's go back, and then let's see the same number of renewable energy scenario. As you can see already, we have much less bio and much less coal, and about half of a gas. And we have less hydro and less nuclear, while we are having much more generation from solar and wind, which sounds very nice, sounds very good. In many cases, in terms of sustainability, environmental sustainability, I would say. So let's have the number here, 27782, 179,431, 1467, 182398, 741, and 8859, 4979, and okay. This is the annual generation of example country, but this is Japan because I'm using Japan as example country. Let's see what happens in Indonesia. We have much more generation from solar and wind, but still number is minimal. Because the number is minimal, its impact to core reduction is very minimal. Basically, solar and wind replace the core, nothing else. That's very interesting. Yeah, it basically replaced the entire, not I wouldn't say entire, but small amount of core. And what about Korea? Someone is working. Let's see the Philippines, and we have more renewable wind and solar, and we have less other renewables. Probably less other. I assumed these other renewables as like conventional biofuel. So which has
Actually, I have a feeling it's geothermal.
okay, it's geothermal.
Yep.
You know, there is an interesting story about geothermal in South Korea. South Korea tried to build geothermal power about 10 years ago or something, but there was a big, I wouldn't say big, but there was an earthquake at the site, and then everyone turned against geothermal, so we can't have it at the moment. Politically, not really easy, but I think geothermal is a good option. And safe one. Like Iceland, they use geothermal a lot. And renewable replaced coal in the Philippines, so that there's always pros and cons, right? When renewable replace coal or nuclear, which is baseload generation, as you can see in the chart in the plot, the pattern becomes much more complex, which means you need more careful control of the electricity grid. You need more battery and more backup systems, and usually that's what happens. And let's see the Pakistan. In case of Pakistan, almost the same. Not I wouldn't say almost the same, but less core power, slightly less nuclear, and less other fossil. What is other fossil fuel in Pakistan? Is it geothermal or something else like bio? Okay, it's interesting. Other fossil cannot be bio or something. Probably some conventional oil or something like that. You mostly could be oil. And what we have Korea. So in Korea, gas, hydro, nuclear, coal, bio, they all reduced, and we have much more solar and wind. Something that you can try later when you have time after the course. You can have a look some different scenario. So for example, I'm going to show you. So in case of nuclear power, it is not really like flexible, right? I mean, technically it is flexible. However, no one really uses nuclear power as flexible source because that's pretty much the cheapest one. So what you can try to have a look is P min. You can set up P min PU of nuclear power as 0.8 or something like that. Then when you have nuclear power, yeah, I'm sharing my screen. Can you see it? This Excel? Yep, I'm talking on this Excel sheet. Yep, thank you. Okay. So what I would suggest you to try is adding PMIN PU on nuclear power, say 0.8 or something like that, and then P max PU is gonna be something like 0.95 or something like that. Then nuclear power will generate between 80% of each capacity factor up to 95% of each capacity factor, right? Then nuclear power will generate electricity more like nuclear power rather than very flexible renewable energies, flexible source like gas or coal. So this is going to be an interesting try that you can have a look at. And as we have generation, what follows after this generation? So we covered all the countries, right? So Pakistan has the fix. I Yeah, I think Pakistan could be. There is some interesting point of Pakistan. I mean, this big drop on the day 4 and night due to, I think, this high wind generation can be a bit problematic for grid operator because the drop is pretty significant. How to smooth the drop is going to be a big question. And then what we would like to see is going to be the capacity factor. Capacity factor is a annual generation. So basically average generation of the electricity system. So if average generation of wind power is about 30% of each capacity, then we say each capacity factor is 30%, right? So we are going to see the capacity factor. But capacity factor is not something that you can just type and find in the output. You need to calculate it. Okay. So we are going to calculate capacity factor. How? We already did most of those things First, we need BAU generators. It's a small fly. BAU generators underscore T, and its total output by fuel, and then divided by 8,760 days. Usually 8,760 days, but I think it was there was one more day in 2024.
Yeah, that's what I was gonna point out. Yeah, it's a leap year.
Yeah, thank you. This, yeah, 8,784 in 2024, because our data is 2024 data. And then divided by network. Thank you, Charles. 3 copies. Network BAU generators dot p nom opt. And then if we run it, this is the capacity factor we have of the BAU scenario. So bioenergy runs as 93% because basically it runs as a base load, and then core 60% and gas is 0.5%, which means core becomes basically a what is that, peak, yeah, peak generator, and then hydro is 99%, which doesn't make sense too much because hydro, you don't have that much water in 24 hours, 365 days, or 366 days in this case. And then nuclear power is 97%, which seems too high because in Japan, nuclear capacity factor is usually about 80%, 85%, same in South Korea, but about 20 years before the Fukushima incident, nuclear capacity factor in South Korea was 99%, 99.5% or something like that. It was hugely high, it was very high. And 17% of solar capacity factor and 23.5% of capacity factor of wind. Now we are going to have the capacity factor for renewable energy scenario as well. So change BAU to REN and then run it. And we have a pretty different number, right? We have a much lower capacity factor of all generators, right? And also we have lower solar and wind because solar and wind are curtailed, right? That's why we have a bit lower solar and wind output. Now we are going to copy and paste this value to our slide in the capacity factor chart. So come down to page 21, find your own country. And we have 2 capacity factor values. Can I just copy and paste? No. 93.3%, 60.9%, 0.5%. Line is basically 100%, 97.7%. And then other fossil fuel is 10%, 10.9, and then solar 17.3, and then 23.6 is wind. And in case of high renewable in Japan, 60.6, 36.0, 37.0, 0.2, 73.7, 64.9, and then 0.5, and then 10.0 and 20.0. So in case of the Philippines, the capacity factor of wind didn't decrease at all, but coal decreased a lot. And solar also maintained. And what about Korea? Actually, capacity factor of South Korea is a bit too high in case of solar and wind. They are more likely 13 and 22. So wind is fine, but in case of solar, 13.5 is basically a normal, and much less nuclear, 73. So high renewable seems much more realistic to me in case of South Korea. And what about Indonesia? Because Indonesia doesn't have much renewable energy sources, adding more renewable energy sources really doesn't decrease capacity factor of other country, other sources, right? It reduces small amount of core. But I really like this result of Indonesia compared to the other countries which basically the generation wind, I'm sorry, which solar and wind replaced all the other sources in Indonesia. There might be a chance that solar and wind directly reduce core quite a lot, I think, but based on the assumption that we have of this model. So I wanted to cover until the emission, but I don't emission and then some other like a cost factor, but I don't think we are going to have much time. So I'm going to wrap up today's session here. But before I release you guys, I want to ask you to do just one favor for me. So we get the number for the capacity and the generation and then capacity factor. As you can see in the example country, I wrote some very small note on what I found interesting. I mean, those notes need to be changed, right? Those are the notes that I put before I changed this example data. So I need to change it. But if you can add a couple of notes on your own target country, that will be really great. Doesn't need to be very long or doesn't need to be very complicated or something, but can be just one or two lines that what you found. It doesn't need to be a deep analysis. It can be just observation. That's totally fine. Okay. Okay. Thank you so much for today's session. And if you have any question, please let me know. And we are going to have the last session next week. And again, we are recruiting the trainee for the third semester on GIS. We are going to, I'm planning to have two sessions. First half for those who never used the GIS, and the second half for those who actually can use GIS. So if you are already available to use GIS, but you want to know how to calculate, like how to estimate renewable energy potential on in your own country, or basically using the example data set, you don't need to follow up the first 4 week, but you can just focus on the last 4 week. I'm going to have a little different structure this time. Okay, so if you have interest in, please apply through the application link that I sent you. And then, yeah, that's all I think. Thank you so much today's session, and see you next week. I'm going to update all those things that we have done today on our Google Drive right away. Thank you, Amanda. Thank you, Charles. Thank you, Boram, and everyone. Thank you.